Welcome to Mr. V Teaching Math. In this session, we're looking at the properties of lines. If I take two lines and I cross them like this, something interesting happens. Let me demonstrate. I'm going to take my protractor. And I'm going to do a little bit of measuring. 0, I go along the top. This comes out to 120 degrees. And if I measure this piece over here, 0, and I go this way, this comes out to 60 degrees. That is, after all, a straight line, and therefore these must be supplementary. They have to add up to 180. So that makes sense enough. So let's take a look over here. I start at 0, and I measure all the way over to here, and this ends up being 120 degrees. I start at 0 and I measure to here, and that's 60 degrees. You see an interesting relationship. That one and that one are equal, and that one and that one are equal. In reality, anytime two straight lines meet, the opposite angle are equal. This will automatically equal this. Those two will be the same, and this will equal that. Anytime two straight lines intersect, this relationship occurs, which is an interesting relationship and quite useful. Now, what about something like this? First of all, I have to make sure that you understand what in the world these things are. These are called parallel lines. That means two lines that maintain exactly the same distance from each other, continue on into infinity, and always remain the same distance. And by the way, if you have to draw them, the easiest way, take a ruler. And these are the symbols that indicate that they are parallel lines. So now let's take a look at this interesting relationship. First of all, this is in there. Just take a look for a moment so you see what I mean. This relationship, where two opposite angles are equal, that exists right there. And what does that do for me? Well, let me demonstrate. It saves me some work. I put down my protractor and I start measuring. 0, looks like I came out at about 124. So this is 124 degrees. That's good. This is 124 degrees then. Automatically, it works exactly the same. And I don't even need to measure over here. From 124, how much more do I need to get to 180? Well, this is 56. And this is 56. Those are automatically equal. Now, how does that connect with this? Well, you see, this angle is moving in exactly the same direction, exactly the same position. I mean, it's farther down, but it's going to intersect in exactly the same angle. So if I were to take this and measure it, this turns out to be 124 degrees. And the same pattern follows. In reality, when given a figure like this, I only need to measure one angle and I can fill in the rest. Let me demonstrate. Here's the example I was working on a moment ago. So I go to this figure, and I go like this, and I measure. 0, we're looking at about 105. And now I'm done. I have just measured every single angle in this figure. That's all I need, because this will be 105, this will be 105, this will be 105. How much more do I need here? I need 75 here. That makes this 75 here, this 75 here, and this 75 here. And that pattern holds true anytime you're dealing with parallel